Hello everybody, good evening and a very warm welcome. My name's Hayaatun Sillem. I'm the Chief Executive here at the Royal Academy of Engineering and also at the Queen Elizabeth Prize for Engineering Foundation. And it's my great pleasure to welcome you here to Prince Philip House this evening for our panel session on moving towards actionable solutions to wicked problems, which is a great and fascinating topic, and I'm really looking forward to getting into discussion with our brilliant panellists here. So, at the Academy, we talk a lot about systems approaches, but maybe it's not always obvious to everybody what we mean. So this is a topic that could take up pretty much the whole time, so I'm not attempting to give a comprehensive definition. But I would say that for us, systems approaches, systems thinking form one of what we call engineering habits of mind, those fundamental ways of thinking that make engineers engineers. And so what we're really referring to is how different components within the system, whether that's people or organisations, information, data, interact with each other to perform a common purpose. We at the Academy have strongly advocated for systems approaches to have a role in policy making, where you find many, many complex challenges. And so we've advocated for that in the context of our aspirations to achieve net zero, for example, also in the context of building a resilient healthcare system. And one of the ways we do this is through our policy fellowships and our work through the National Engineering Policy Centre, where much of what we do revolves around a system helping government to adopt a more systems-based approach to tackling some of the policy challenges. And we also have an array of international programmes that also adopt systems approaches to try to tackle some of our most knotty global challenges. We have a particular set of activities under the banner of Engineering X that was co-created with Lloyd's Register Foundation. And I think some of that might come up this evening. In today's discussion, we're going to be exploring how systems approaches from the world of engineering can, in practical ways, help decision makers, including policymakers, to deliver actionable and socially responsible, equitable solutions to wicked problems, especially where the problems are so complex and interconnected that there really aren't any clear, singular solutions. And I'm delighted that, bearing in mind this is quite a big and difficult topic, we have three excellent panellists to help us navigate our way through that. So, starting to my left, we have Professor Sarah Sharples, who's the Professor of Human Factors at the University of Nottingham and has led research in transport, manufacturing and automation. Thank you for joining us, Sarah. Next, we have Dr. Guru Madhavan, who's the Senior Director of Programs at the US National Academy of Engineering, our sister academy in the US. And Guru has recently published a new book called Wicked Problems, How to Engineer a Better World. I can thoroughly recommend it. I have read it already. And he will be sharing some of his insights based on the research that he did for that book and telling some interesting tales from systems engineering that help us understand how engineers can engage with wicked problems. And then last but by no means least, we have Professor Yasmin Merali, who is the Emeritus Professor of Systems Thinking at the University of Hull. And Professor Merali has supported the Academy's recent Engineering X programmes, which I referred to earlier, as well as a recent Frontiers Symposium in Colombia. And she is an expert in complexity theory. So you can see we have three very appropriate panellists who are going to guide us through this topic. It's important that we are going to also hear from our audience. We would love to have your comments, your questions, your suggestions. So we're going to have plenty of time for audience interaction. But before that, I think we ought to set the scene. So I'm going to invite our panellists to just talk one by one about how their work contributes towards our essay question or exam question of how to create more actionable solutions to wicked problems. And I think, Guru, we're going to start with you. So I'm going to hand to you to spend a few minutes setting out your stall. Thank you.
So let's start with solutions to wicked problems. And I think it starts with this fundamental defining identity engineers have, they carry, they're very proud of. We like to call ourselves problem solvers. Therein begins the problem, because wicked problems require more than problem solving. To better understand this, we need to, I think, engage with the inner nature and the inner character of life's most perplexing problems, which I think is the subject of our conversation. My mentor, the legendary Russ Ackoff, said that not all ways of viewing a problem are equally productive, but the most productive ones are seldom evident. So what do you do about it? And to better engage with wickedness, we need to understand what composes wickedness. And the way I have pursued this formulation is to understand three different classes of problems that interact to produce wickedness. The moment you run around saying a wicked problem can be solved, deep trouble awaits us. So let's start with the types of problems that are actually solvable materially, mathematically, strategically. These are what you can call hard problems. Have you used your phone to check into a flight? Have you used a QR code to order tacos? Sure. These are all hard problems that can result in hard solutions. They can actually be buckled down and they can yield, they can succumb to a solution. The second class of problems, and in fact, the first one can be dictated or derived from customer requirements, client contracts, and whatever. The second class of problems get a little bit more interesting because they involve the human elements that Sarah knows a lot about, and also involve the organizational perplexities. And making a car, making millions of cars is a hard problem. But managing traffic is a soft problem, which is actually a harder problem. Now, I think, how do you go about expanding a freeway without consulting constituents or the communities that are affected by it? How do you charge? Or how much do you charge for it to enter London and exit London and whatever it is? So it gets into this economic concepts of peak pricing and so forth, which are hinged, somewhat offensively titled, concept of price discrimination. This is an official concept in economics. So this is just to illustrate how soft problems work. And the third class of problems are messy problems, where human values, belief systems, ideologies really influence how one even goes about thinking about a subject. We're all familiar with groupthink, correct? But scholar John Warfield identified a concept called spread think, which means people can't agree on the essential elements of what a problem is. And the question comes about, how do you deal with the messiness that is rooted in cultural rituals? An example that has profoundly influenced my thinking and my own work over the past few years is what happened during the Ebola crisis a few years ago. The local burial rituals significantly influence the transmission of the virus in the early stages. About 60 to 80%, whether it's Guinea or Sierra Leone, experience this tremendous transmission of this. And people distrusted public health leaders because the local religious leaders guided the funeral rites and so forth, which means people touched, they bathed, they kissed the dead bodies, their relatives in these cases. These are centuries of tradition, perhaps millennia of tradition that you just cannot flip like a switch. And that's when, so people distrusted public health officials and they started doing secret burials. And of course that created more problems. And this is where the technological element comes in. So the way you think about, let's say there is a hard component in this messiness, which is, can you imagine barcode, satellite tracking of supplies and so forth? Sure, there's that. We have all experienced that in the past few years, having survived the COVID crisis. The soft dimensions, can you do surveillance mapping and maybe almost get to borderline antibiotic resistance type of things where the system is a bit more, gets smarter than us? Yes, we have experienced that too. And finally, this is where, unlike a hard problem that can be solved, and unlike a soft problem that can be resolved, which means you don't have a best option, you can get a good enough option, like managing traffic, a messy problem needs to be dissolved, which means transforming it into an altogether different form so the problem vanishes. That requires some effort. Engineers are extremely good at hard problems. They are getting good at soft problems. We still have no clue what's going on in the messy problem space. Wickedness comes with the interaction, multiplication, addition, division, subtraction, call it whatever, of these hard, soft, and the messy elements. Now, that's what two scholars, Horst Rittel, Melvin Weber, wrote about in 1973, a classic paper on wicked problems. They say how they are boundaryless and they blur our understanding of these problems, and where one problem begins and where the other one begins is confusing. There are no entry and exit points, and there are no start and stop signs. Trouble. So we if we say we can solve a wicked problem, we are only dealing with the hard problems, and we are deluding ourselves with the broader set. So to engage with wicked problems, one has to simultaneously solve, resolve, and dissolve wicked problems. So hard problem can be optimized, point made. Soft problems can be satisfied, which is a portmanteau of satisfying and sufficing. No best answer. And finally, messy problems need to be idealized, which means it's a state that none of us are capable of even understanding in the first attempt. So we need to do all three things to better engage with wicked problems. How's that for a start?
That was a very engaging start. Thank you, Guru. Just what we were looking for. I'm going to turn now to Sarah. I'd love to hear your perspectives on this, please.
Yes, so thank you very much for the opportunity to sort of hear from my fellow panellists today, actually. As Hayaatun mentioned, I'm a professor in human factors. I'm also the chief scientific advisor for the Department for Transport, but we're in a pre-election period at the moment. So I'm very much here with my professor of human factors hat on. The way I describe human factors to non-specialists is humans are fallible and humans are brilliant. And our job is to minimise the impact of human fallibility and maximise the value of human brilliance. And many complex systems in which we see wicked problems have people all over their parts of them. And so my perspective on wicked problems, and I really agree actually with your sort of typology of the different types of the sort of hard, soft and messy problems, is that when we have people in the system, one of our biggest mistakes we can make is to think they're the weak spot in the system. Yet if we think about resilience engineering, and if we actually think about many incidents that have happened in the past, we know that very often people are the strength of a complex system. I'm going to give two examples which have sort of exercised my mind over the years, and they are both inspired partly by the context of transport, but also by manufacturing and healthcare, where my work takes place as well. The first one is what I've sort of come to term the energy enigma. If we think about decarbonisation, we know that decarbonisation is a wicked problem. It has many complex parts and it is societally embedded, which is one of those things that we know is often very prevalent in the wickedness of these problems. If we take transport, it's so complex even within the sector of transport. We look at electrification in the automotive sector. We look at aviation, where there's potential solutions around sustainable liquid fuels. We look at maritime, where we have multiple fuels emerging as opportunities. We look at rail, which has electrification as an option. But all of these things require very different types of investments and considerations if we're going to bring everything along together towards some of the targets that we need to achieve. And transport's only one part of the very large picture of decarbonisation. So we can't work in individual silos in order to solve that problem. The second example is one that is inspired by my favourite academic paper. I think every academic's got a favourite academic paper. And it was written in 1983 by someone called Lisanne Bainbridge. And if any of you have ever heard me talk before, I've probably mentioned the paper, The Ironies of Automation. It's got a beautiful title that says exactly what it is, The Unintended Consequences of Automation. Read it if you haven't already read it, because it's a really well-written paper that wouldn't get published now in the academic literature because it doesn't have lots of data sets within it. It's a description of her experience in the process control industry over many years, and she highlights many ironies, unintended consequences. The one I want to point out is one that I always find very pertinent, which is that we tend to automate the elements of a complex system which are easy to automate. And what that means is we end up with a potpourri of leftover elements of tasks that we then have to cobble together to make a job. And surprise, surprise, when we've automated part of a role and we've left another part to still be operated by a human, we often lose something in terms of the overall systems understanding and the information that's presented to the user. So I think one of the things that really inspires me to try and take that step back, that systems perspective, and address things as a wicked problem, is thinking about how we can recognise what's caused this potpourri, this sort of piecemeal automation of complex systems, and how do we make sure that we still have meaningful tasks and roles and jobs that enable people and people's brilliance to be maximised in complex systems.
Brilliant. Gosh, I'm scribbling notes here because I'm going to steal shamelessly from all your very quotable comments that the first two panellists have shared. Thank you so much, Sarah. And I'm going to turn to you, Yasmin, now. I'd love to hear your thoughts as well.
Okay, so I'll just remind you, I'm Professor of Systems Thinking, right? I don't actually do anything useful. But what I do, which I kind of immodestly would say contributes towards dealing with wicked problems, is try to introduce some new thinking into the systems paradigm. And that's from the science of complex adaptive systems, very much drawing on biological systems. So a complex adaptive system, if you think about biological systems, because we all know them, is quite remarkable because it can do two things. It can stay stable through environmental perturbations, and it can also transform itself during those perturbations. And both those things are possible because intrinsically, those systems are network systems. And there is an elegant design of the network structuring, and there is an elegant design of the dynamics of those networks. So to save myself falling into a lecture, I'm very happy to talk to people about how this works. But I think one of the key things is that there has been a great deal of attention paid to the structure of networks, but less to that relationship between structure and dynamics in management sciences. But of course, the mathematicians and the physicists have done a great deal here. And of course, a lot of the stuff you might have seen on social network stuff is now drawing on that material. So come back to the kind of discussion we're having. I do two things, I think, that are useful. So if we think about what Guru said about this kind of messiness and things are connected to everything else, what we've heard about the kind of partitioning of things or doing things are easy, losing coherence, then one of the kind of key things is that we need to understand that wicked problems are actually a symptom of systemic behavior. They are systemic things, right? A system is things connected together, and these are systemic things, and they're systemic things arising from network systems. So one of the things that I try to do is to say, okay, given the current context, you know, lots of dynamism, lots of unpredictability, etc., which are all kind of characteristic of wicked problems, but also at the macro level for us, where we are today, organizations need to have transformational capabilities to help them understand how they can use that potential of the networks to try and develop this capability for transformation. And the other part of what I do is to try and show them, get them to think through what they're doing, very much in the way that Guru and Sarah have talked about, where any interventions they decide to make have to be systemically coherent, right? So this comes back to the thing about we only deal with what we need to deal with. The other thing, if we draw on natural systems, is it tries to be as conserving as possible, because there is a tendency in transformational change to say, we want to be the new man person, so let's just chuck everything out and start from fresh. And nature doesn't do that. Nature is amazingly conserving. But what it does, it manipulates what it has in clever ways to give you that requisite variety. Now, many of you will have heard about Ashby's law of requisite variety. Yes, a system must have the requisite variety to match its context, environment. Well, the network stuff allows you to generate that variety as and when it's needed. So you don't start out with it, but it is the way that you organize yourself, the way that you activate your networks, the way that you use information that allows you to do that. So fundamentally, those are the kind of things that I think, when it works, do actually allow us to influence what we do and how we do it and deal with those wicked problems. And I think we're going to talk later about the kind of relevance to engineering, so perhaps I'll say a bit more then. I don't know how we're doing for time, so I guess it's time I stop.
Well, you stop where you'd like to stop, Yasmin. So if you finish that train of thought, then I'm happy to open it up to the questions. But Did you want to say anything else?
No, so I think for me, this is really, really important because of two things. One is we do need to sort of understand that, and I think Guru kind of referred to this, it's not about problem solving, it's about systemic change, right? So what you do with these kind of methods I'm talking about is you go underneath the bonnet, but what you're saying is what you're observing is really a macro level phenomenology, right? And you've got people on the bottom, right, doing stuff, working around these automated systems you put in and so on. There's a lot of workarounds. And what we have in research and management is a missing middle, right? So we have very good data about case studies and lots of information about the very micro stuff we do. We have amazing data sets, and even more amazing data sets, and some of them are of doubtful quality now, I know. But, so at the high level, we can do all kinds of smart stats and say, well, this is what we can do. But the middle layer is not there. So the mechanisms in those layers are really, really important, and they are context dependent and they're time dependent. So time matters. And I hope we'll come back to this issue of time later, because that is a critical thing that I think is missing from a lot of the discourse around this.
Excellent. Well, this has been a brilliant example of the extent to which I'm going to pick my words carefully. I think I'm going to have to park the word solution. Achieving systemic change requires us to draw on a variety of disciplines and perspectives to blend the theoretical and the experiential and practitioner knowledge. So I'm going to ask all of you, well, that's great as a concept, but that's really hard to do in practice. So how do we get that integration? How do we maximise what different types of expert and participant in this experience can offer? Sarah, I might start with you on this.
It's a really interesting question, actually, because I think there is a tension between this type of really rich conversation and the practicality of systems thinking in any sort of organisational or operational context. And I was chatting with one of my human factors friends over the weekend, actually, and we were talking about what it is about systems thinking and why we all think in this certain way. And neither of us could put our finger on a particular time when we'd been sort of taken into a classroom and said, right, we're going to teach you to think in a systems way. It sort of was embedded in our discipline from the very start. And I think that's great, but it's also a real challenge, because what that means is that, and we were talking about this before, for many of us who are very embedded in a discipline of systems thinking, actually it's an art rather than a science, and it's a mindset, and it's a natural way of thinking. If you ever go to a conference with a lot of human factors specialists, it's great, because over breakfast we all analyse absolutely everything that is wrong about the hotel, and for once no one tells us to stop talking about something so boring, because we're all terribly interested in it. And so we need to realise that there are different mindsets from different disciplinary perspectives that aren't necessarily embedded into natural ways of thinking. I think one of the things that I've always found very useful to try and help people take a sort of wicked problems or a systems thinking perspective, but make it sort of tangible, is just to think about asking the question why, and not to jump to the first solution that comes through. And I'll give you a bit of an example, because very often we think about why in the context of when things have gone wrong, but it can be really powerful to think about why in the context of when things have gone right. Now, some of you may remember, or you may not, because it went right, that a few months ago there was a crash with one of the Japan Airlines flights, and the plane caught fire. And everyone on the passenger plane, unfortunately there was a crash with a smaller plane, but everyone on the passenger plane evacuated safely, despite the fact there was a very, very significant fire, and despite the fact that it actually took 10 minutes to do the evacuation, which is much longer than normal. And I was, in preparing actually for this, I thought, well, that's a good example of a sort of a why. And I did a bit of sort of reading about what happened in that particular incident. And it's a classic wicked problem scenario. So it could be everything from the effectiveness of the safety briefing that reminded people to not take baggage with them, so they evacuated safely, cultural issues around obeying instructions and the confidence of the staff to deliver those instructions, the physical signals of the fire that was around everyone that showed the gravity. But the one that really hit home to me was Japan Airlines has a really generous policy on checked hold baggage. So most of the baggage was in the hold, not in the overhead lockers. So the temptation to remove the baggage from the overhead lockers wasn't present. So that's a really interesting example of systems thinking. And I don't know whether the rationale for the hold baggage was one that was embedded in safety, but it turned out that that was one of the consequences. So I think there's a couple of things. There's asking why, learning from when things have gone right, but also having the opportunity to think around beyond the engineered system and think about the wider context, that enables some of these systems to work.
Brilliant. That's a great example. Yasmin, I'm going to pass it to you next.
Okay, so, I think picking up on what Sarah talked about, it is that contextual importance, right? So to try to understand what is happening, the question why is really, really important. And I think we were kind of beginning to talk about this need to get different disciplines coming together and use systems. And what I've found with trying to kind of get people excited about using this kind of complex adaptive systems paradigm is actually focus on the thing that they want to do, right? So if you focus not on the theory of it, not on the rationale of it, not on the glitz of it, right? Because management theories are always very glitzy and you always get a new one that comes up. And, whilst we might actually think that you don't talk about, and I agree with you quite often, we don't talk about why things went right. But unfortunately, sometimes people who too much about why things go right come up with formulae or causal stories, right? And we're all telling stories when we look back and say what's happening because we're selectively picking out what happened and making sense and piecing together a story. And very often in organizations, the things that went wrong don't even get recorded as stories because there is, well, it didn't work, so why would you be interested in using it? And that's a rich set of data that goes missing that is very, very valuable. The other thing that I think is important about this is going back to the network thing I said, you do need to design an interdependence in the what people are doing, right? In what they're interested in. And that kind of goes deeper because it's got to be a genuine what matters to them. And that goes back to work design, it goes back to organizational design, it goes back to values and what they mean. I mean, I remember the 90s, I am as old as I look. And, it was very fashionable to go around with little business cards that had the organizational mission on it. And it meant nothing. It was words, it was an idea. And it didn't actually follow through from what does a mission mean when you translate it down to the person on the ground. So I think all those things help to make it, to try and deal with it kind of practically doing it and getting people together.
Wonderful. Now, I'm conscious that we're having a great chat and I've got lots more questions and I'm going to come to you, Guru. But I want to warm our audience up, okay? Because I'm going to ask Guru to give some thoughts and then I'm coming out to the audience. And I'm going to try and exercise some self-discipline and hold my questions back. But Guru, I would love you to sort of help move us into this practical action space. Can you give us some examples of the sorts of approaches we're discussing being used in concrete, tangible ways? Because I think this is always the challenge we face. Yeah. We can buy into the concept. It's quite hard to do it in practice. Or not. Come on, tell us, Guru.
Now, I'm going to try to synthesize some of the points here. Let's start with 3 meta points. First, let's talk about systems engineering. I was trained in control systems engineering, so hardcore Newtonian to begin with. But then it took my studies in biological evolution to convert me into a Darwinian, where I was dealing with complex systems, complex adaptive systems particularly. And that transition happened just within a year or two kind of thing. And that was enough for me to completely reframe my view of the world to the point that it made me more confident to engage with the more complexity here. So I think engineers are largely still rooted, entrenched in the Newtonian domain because it gives us comfort. Who doesn't want crystallized answers and so forth? Easy to teach, easy to grade, easy to rank one another, easy to judge one person over another, easy to assess impact and whatnot. Darwinian, not so much, as Yasmin was talking about. And I think that's something to keep in mind. So systems engineering, as it has evolved in society, and I would like to suggest that it is not some specialty situated in an AIE, acronym-intensive environment. It is a convening sensibility. And how do you try to gauge all the dimensions of a problem? To make this point, I've been thinking quite a bit about my ancestors 6,000 years ago in northwest India, in present-day Pakistan, people who engineered the Indus Valley. And this was a time where there was no known specialization in engineering. There was no civil engineering as we now know it, or they didn't use building information modeling, nothing at all. They knew how to create a civilization supporting, a civilization enabling system of sanitation. Cities, the streets ran north-west, east-west, and they knew how to separate clean water from feces, which is the hallmark of our survival. And they knew how to taper the tubes at the right angles. And I think that required a much deeper abstract sense. So this, since we were recommending some excellent papers, I would highly recommend a paper by Jens Rasmussen, who wrote a paper on abstraction and aggregation hierarchy. A systems engineer should be really good going from the spec to the system. A specialty engineer would love to avoid contradictions, but a systems engineer, a good one, actively embraces them, proactively puts in the pre-work to reduce the rework. And I think that requires practice. One might question, is this even unnatural? Because what I said about the Indus Valley sounds almost instinctive, because there's no other way for me to make sense of it. There was no way we could divide that kind of a system, which ultimately influenced the Greeks, Romans, and modern-day New York City's sanitation system. It just came as a package. So my theory is, provocation is, maybe we were all originally to begin with systems thinkers, systems engineers. We just got too busy hyper-specializing to the point beyond recognition. Now we're struggling to put them back together. So there's something to think about it. Maybe we need to go back to the original starting point here rather than teaching ourselves how do we make systems thinking work in practice. Again, a provocation. So in terms of concrete perspective here, concept development is the heartbeat of systems engineering. Whether it's aerospace or my former trade, medical device development, you need to have an understanding of what the system is actually going to be doing. So the first step that we do is develop what's called ConOps in trade jargon, a concept of operations. Which is basically, for our purposes, we can call them as narratives about situations that we haven't necessarily experienced, which is pretty much the domain of wicked problems, because they keep changing the moment you try to intervene, as Yasmin beautifully put it. So how do you develop a concept of operation? So just to shape my thinking on this subject, I went to the classic, the perennial, the foundational concepts in engineering that have guided our work. There's probably no disagreement among them. On the problem formulation, sure, there might be, but let's look at some of these things. And the way I tried to put them together in terms of requisite variety we were talking about earlier, 6 essential elements, 6 essential concepts that kind of pull together to potentially identify a concept of operation. They are efficiency, not as a final point when I was a Newtonian, but as a starting point. If you use efficiency as a starting point, your worldview completely changes. Because when I was a Newtonian, I was just chasing how to get to 100% from 93%, which was altogether different formula than, okay, now what do I do with this 100%? Is 100% good, or is 99% good with that bio? So it's a very different kind of situation. The second element is vagueness. And I didn't fall into the trap of using uncertainty analysis, which engineers are really good at doing. Uncertainty being just one element of vagueness, the vagueness associated with the problem set. The third one, I didn't fall for the standard risk analysis part of it. I went with the broader, the conditions that give rise to vulnerabilities, where risks are created. So you got efficiency, you got vagueness, you got vulnerability. Then you need brute force safety. Without safety, we are nothing. When you walk on the street, you need the psychological safety of feeling, or when you're working in an environment, you want to be recognized, you want to be seen, and so forth. So there's safety. Then in a society filled with relentless innovation speak, I think we need to go back to the roots of maintenance, the concepts, the discipline that still allow us to live healthful, productive lives, from sanitation to wireless networks, whatnot. So maintenance as a kind of an authentic, original source concept of engineering. 80% of engineers work in operations and maintenance. the very minority of the people who are innovators take all the credit because that's where the value is being deposited, so to speak. And finally, resilience. Now that, I think, gets into the kind of messy arena. How do you think about resilience? If it's carpentry, it's one form of resilience. Stress over strain, Hooke's law, and boom, you have a specific answer. You build ships with it. But how do you think about problems of homelessness or housing displaced individuals and so forth? Very different form of societal philosophies there. So you put them all together as a package: efficiency, vagueness, vulnerability, safety, maintenance, and efficiency. You filter a problem through these 6 filters. There's no ranking in this hierarchy. It's very much like musing. You're trying to braid harmony, melody, form, and so forth. So nothing is more important than the other. The fact that by merely bringing these together could help us provide a kind of a better formulation of the problem that we are dealing with. We can get into applications, but I'll stop there.
Good, thank you. This is all fascinating stuff, and everything you're saying is prompting 10 more questions in my head, but I really do want to bring in our brilliant audience here. So let's take a pause. Let's gather a few comments or questions. We've got a couple of microphones. Who would like to kick off? Yes, please. I can see one in the middle there. And then, Keris, there's one here. Thank you as well. So we'll go to the middle first. Sorry, right, you're stuck. Thank you. Would you like to just say who you are before you ask your question?
Hi, Sir Richard Judge. Just picking up where you ended in your intro speak, Yasmin, about time. Really interested in perspectives on slow and fast feedback loops and actually how that affects. And that picks up the political world, it picks up the resilience you just talked about, and it brings up all sorts of issues. And you're just getting to that point. I'm really keen to hear more.
Thank you very much. And we'll go to Natasha over here, please. Natasha, please, yeah.
Thank you. I'm Natasha McCarthy. I'm an Associate Director here at the Academy. This has been so interesting. Thank you so much. It reminded me of, I was once at a workshop talking about narrative, and I was interested in the role of narrative in engineering policy and how engineers can tell stories about the future. And, you know, stories are more complex in a way than, say, laws or equations. They're more about complex systems. But I got a really interesting response from somebody who was an economist working at the interface of philosophy and policy, which is like, well, this is really interesting because we think about these complex problems, but engineers actually have to build something at the end and they actually deliver something. And it made me think about 2 things that I thought I'd like to hear the panel talk about. One is, can the talk about wicked problems be a bit stultifying sometimes because it seems too hard? But also, is one of the challenges of bringing, say, interdisciplinary groups together, that different disciplines have not only different terminologies, but also different objectives?
Interesting questions. Great. So let's start with you, Yasmin. You just gave us a little hint of your thoughts on time. Let's hear more about that.
Okay, so one of the things about time was very simple, which was we're not talking about policy as such today, but if you think about policy making, then the time frames that you use are really important. When you talk about the efficiency kind of idea, you get very different answers from if you talked about the effectiveness kind of idea. So coming back to it being human systems, that matters because, of course, if you do an intervention, then you want to make a difference to that human system. And when you do that, there is intersectionality. So there is the economics, there is informational stuff, there is education, there is health, there's a whole load of stuff that comes together. And all those systems change with different speeds of time. So if you want to try and get a handle on that intersectionality and you do an intervention, then you really need to think very carefully about how do you model things so that you've got, you know, if you think about pieces of A4 paper, here's one that's about the economic system in a particular locality, and conditions really matter, right? So the context matters. But you're going to do this kind of map across not just a locality, but, you know, a large thing. Then you might do one about health and so on. And so one of the things I'm working on at the moment is trying to do some modelling where you do that network modelling in fairly sophisticated. But if you think about these 3 pieces of paper, then at any given time, you kind of cut through it. So you have the changing states that you're capturing and you understand then if you link those 3 up together. I'm trying to do a visual, I don't know whether it works because I usually draw pictures for people. That's one way of thinking, reconciling those different cycle times. And I think to me that's important. But also if you talk about the rest of the stuff that people talked about, which is, you know, the technology in place is very different from the technology created. And that comes back to the intersectionality problem And again, you know, engineers need to think about time very much because, and I'll stop, but one thing I want to throw in because we might pick up on it is the stuff we're seeing about AI and so on has actually moved the locus of intelligence. So what can you be responsible for as engineers when you put something in place, when you're building stuff in? And that draws you into the ethical questions. And those also require you to think about what for a time frame do you think about for ethics?
Gosh, I feel like we're not going to be able to answer half of these very deep questions, but let's keep going. Thank you so much, Yasmin. Very interesting. Sarah, I'll turn to you. Feel free to add anything specific on time, but also I'd love to hear your thoughts on Natasha's question.
So it was a really great question, Natasha, in terms of that sort of disciplinary, different ways of thinking, but also that terminology of wicked problems. And it made me reflect. So in my sort of working life, whether it's at the university or in the department, I have conversations during the day and I have conversations in the evening. And I find myself talking about things like wicked problems and systems thinking in conversations like this and settings like this, and less during the day. And actually, it comes back to the point about time. Because whether we're working in universities or working in engineering organisations or working in government departments, when we're sort of during the day, we're often focused on delivering whatever it is we, as individuals or in our team, are expected to deliver. And the way that organisations end up being designed is that we have to compartmentalise that delivery. And again, that could be everything from within the delivery of a major infrastructure project or the delivery of the operational activities within a healthcare setting or something like that. The only way to manage a large organisation is to compartmentalise what's being delivered and then hold different elements of that system to account some way. But by introducing those silos, which are sometimes sensible and sometimes artificial, we're perhaps stopping the recognition of the overall complexity. So I think there's another thing as well, which is sometimes I can see people's eyes glaze over if I use phrases like wicked problems or systems thinking, and I lose the room. And I don't want to lose the room. So thinking about the language that we can use that allows people to change the way that they're thinking and actually allows people to work out what this means for themselves in their own context is really important. And I remember one situation where I managed to do this, and it was with a colleague, some of you may know, Clive Roberts, who's now at Durham University and has worked an awful lot in the rail industry at Birmingham University when he was. And Clive and I have progressed through our careers at very similar stages. But he's a sort of electrical engineer, sort of control systems engineer, very much come through that sort of that route. And I've come from the human factors perspective, and we've both tried to tackle some equally complex problems within the rail industry. And I remember Clive used to sort of get what I said in this sort of context. We'll go, yeah, terribly good, Sarah. And then I don't think he really did get it. And I remember the room I was in when the penny dropped. And I showed him a representation of a complex system using his language. It was something called an abstraction hierarchy that we use in something called cognitive work analysis. And at the top, it has the overall system goals, but it moves right down to the physical functions of the system at the bottom. And you can show that by changing something like a communication system, it can have a linked consequence for the overall abstract function of an organisation. And so I think that we need to respect those differences in languages, and sometimes we need to realise that belligerently sticking to our own terminology is not the way to allow a message to be communicated, but to think about the way to articulate some of these things, possibly compromising some of the complexity that we have to deal with, if that's the way to get the message landing. And I hope if Clive were in the room, he would also recognise the way that I've sort of portrayed that conversation. But I think it's a really important thing for us to be considering.
Thank you so much, Sarah. Again, fascinating. Guru, I'm going to give you a very quick opportunity to respond because I want to go back and get to another group of questions.
I'm just going to riff on this. 2 points. Nothing profound to say here. First is about narratives. One of the most fascinating mathematical techniques that I learned as a student, which I then subsequently struggled to teach undergrad students and so forth, was fast Fourier transform. It's one of the most powerful techniques whose value I recognize only years later. Because what you're ultimately doing, and this is to attempt at the narrative aspect here, most people don't even think about it in engineering. You just click a button and then boom, on MATLAB spits out an answer. But you're trying to deal with the velocity, the variety, and even viscosity, so to speak, of the data points that are coming at you from all different directions. You have to just imagine this. And you put it through the time domain, your mind is not able to grasp it. What Fourier did, the mathematician, said, why don't we just invert it, take it to the frequency domain, and instead of dealing with the dynamics in time, which the brain is not able to process, let's look at patterns. So now you're looking at spikes. Then you say, my God, there's some activity going on at the 25 to 30 hertz region and everything. It's nothing magical there, but it is magic because you're dissolving the problem out of existence. That's what's needed for messy problems here before it gets to the wicked stage here. So now you're looking at pattern recognition, which activates a very different parts of the brain. Presumably that connects to the stories and the narratives part of it. Now it all makes sense. What didn't make sense in the other domain. It's exactly the other side of the coin. That's the narrative part. The second element is, I'll build on what Yasmin said earlier. We use the terms complex adaptive systems. We have all been heard about, there's much been written about it. But I think we confuse two very distinct meanings of the term. First is a complex system that self-organizes with the system as the ultimate target, which means the entire whole system effects are being considered in it. Think of insect colonies. Think of ant colony, whatever, in biological immune system. They organize. Your body's kidneys don't operate separately, so it does what the body wants. So there's that element. Call it complex adaptive system 1, CAS 1. Then you got complex adaptive system 2, where the individual elements have their own respective adaptive strategies. Pick a agency in the federal government. Each of them are doing their own thing. One department is doing another thing in a university. They don't talk to one another. And we have seen the side effects of CAS2 from Chernobyl to COVID to financial disasters and whatnot. We don't clearly distinguish them because both of them have unpredictable properties. Therefore, we synonymize them. So, but the fact that the big design opportunity that we have is how do you convert CAS2 systems that have an agenda of their own, or each of their components, into CAS1? That is, I think, the biggest design problem that we have here. And I'm being fairly meta here because I think if we know how to do that Mother Nature has her own agenda with an open-ended process over millennia. We don't. And our own lifespans are restricted. So understanding the pernicious effects of CAS2, which give rise to complex maladaptive systems. So compared to a century of work on complex adaptive systems, hardly nothing's published on complex maladaptive systems, which is shocking to an engineer who is deeply committed to understanding failure modes, which is a big discipline in our area. So I think these are the two elements I would like to talk about in terms of narrative and the reframing part of it when it comes to adaptive systems.
Brilliant. We are packing a lot in. Yes, please. Thanks, Angus. If you could come to this first here. And then Keris here and then there. We'll take three.
Just jump in.
Yes.
The CAS stuff. So with there is science of complex adaptive systems. All the people say there isn't. So understanding systems that are complex adaptive. So I think it would be helpful with vocabulary to say complex systems which are maladaptive rather than, or complex systems which are adaptive. But that doesn't necessarily satisfy all the conditions for calling something a complex adaptive system. Just a note, just a marker.
Language matters, yes. So please, your question.
Hi, my name's Seb, and Guru, I have a specific question for you. You know, we as human beings, we're sort of inherent generalists, right? We're inherently these sort of complex adaptive systems ourselves, the brain as well. And I really liked your point in leaning into being, going back into systems thinking from the sort of Hindu Valley civilizations. They were inherently systems thinkers, and we've sort of ended up in this sort of reductionist way of thinking. Very useful, don't get me wrong. How do we relearn that intuition? How do we get that back into people's mindsets? That would be my question.
Thank you. We're going to keep going. This way, please.
Bruce Elliott, University of Birmingham, hired by Clive Roberts. One of the things I was hoping to get from this is how do you make a start? Because as I'm reaching the end of my career, but as I've gone through, I've understood that things are always more connected than I thought they were. And I learn and they're more connected. And that means there's more scope for unintended consequences of well-meaning actions. And I think I'm hearing some themes that might be useful here. One's not always to try to resolve or dissolve or whatever the problem, but to try to set things up so that the organisation can deal with the problem itself. I mean, this bit about compartmentalising, which I think you were using in a slightly derogatory way, nonetheless, you have to do it in order to make progress. You have to pick a bit and start somewhere. And then you were talking about models and providing people with some feedback, accepting that we haven't understood everything and therefore some unintended consequences. Three things. What does the panel think? Am I on the right track? Or?
Thank you for your question. And we'll go further along the line.
Hi, Paul Brand from Risk Solutions. I'm curious about what you think we can do to develop sustained responses to wicked problems at the national level. DEFRA, DFT, lots of people are responding, doing systems thinking, this kind of thing. Getting a better understanding of something really complicated, coming up with a portfolio of what we might do to respond. However, in the year or 2 or 5 years that follows, the other forces are pulling the politicians, the civil servants, the system to find simplification, make it simpler, make it cheaper, etc. How can we become more comfortable with it continuing to be a wicked problem, continuing to be something we have to accept the complexity and intervene in that way rather than and resist the oversimplification?
Okay, brilliant. Those are 3 great questions. What I'm going to do is get Guru to give us a concise answer to this very important question around kind of drawing on the good of our intuitive value system, perhaps of our ancestors in the context of Hinduism or elsewhere. And then I'm going to come to Sarah and Yasmin to give us top tips in terms of practical things that anyone in this audience could do, and also a quick thought on how we can not just initiate something, but have that sustained impact that we're looking for. And then Guru, I'll give you the last word on those things, but we're tight for time now. So Guru, going back to our ancestors.
I'll make 3 points. My answer, I'll let you figure it out. It's probably somewhere at the centroid of the triangle, okay? The first one is the notion of what's called hypocognition. We're all familiar with hypercognition. We can pick up all the data sets, our phones are doing the work for us and everything. But it is the limitation that we have beyond, it's like there are things that we just cannot conceive of. And what we end up doing is we go about applying familiar frameworks in foreign contexts. It goes back to this example in early 1800s when the Americans tried to introduce ice blocks in the Martinique Islands. They didn't have any concept of what ice blocks were, so they just left it to melt. So that's the hypocognition we're talking about, the trap of applying familiar frameworks to foreign concepts. Second, it's a mouthful. It's a word called monocausal-taxophilia. Mono-causo-taxophilia, which is our affection or addiction even for single causes that explain the universe. Physicists, thanks. I think that's something we need to keep in mind. And I went to business school simultaneously with engineering school. In business schools, they taught me how to win arguments. In engineering school, they taught me how to solve problems. Right there, I had a split personality here. So that's the second point. The third point is, I'm borrowing from the investor, John Bogle, who called it the worship of hard numbers, where we prioritize momentary precision, we actually privilege significantly over eternal imprecision, which goes back to the specialization, that point that came up that Sarah will elaborate on. So I'll let you figure out an answer in this 3 points here.
Thank you, Guru. Yasmin, I'd like your thoughts on practicality, sustained responses.
Okay, so just one thing about practicalities, but we can talk later if you want. The thing you got right was around managing the context, right? So you don't do everything, but you try and manage a context where people then will do stuff, and then the network kind of sort of allows you to create interdependencies and things that matter to be situated. So the situatedness is really important. And it's also the practicality, because when you want to deal with something, then you deal with the thing that matters at the time. So it's not that you're going to do this great systemic thing, but then you kind of build that map of what are the impacts going to be and where does it go. But also you've got stuff coming in, and the intersectionality matters, right? So different aspects, different dimensions, coming back to what Guru was talking about. And then coming back to the policy thing, to me, the answer seems to be that it lies in devolution. It's back to the place-based thing, because people have got skin in the game. They do intersectionality because it's their lived life that you're affecting. But more importantly, something I didn't talk about because I thought we'd come back to it, was you're creating a generative capability. So any intervention you make, you need to figure out, are you going to create a generative capacity in the population that you're carrying this out in? And it cannot happen unless it is done in that way, and handles the intersectionality, the stability, the people putting stuff in, and having skin in the game, and development is what it's about.
Well done, Yasmin. Really interesting reflections. Sarah?
So, first of all, there's something practical that we can all do, and I actually did it this morning when I was trying to do some systems thinking. There's a tool online, and it's in the Go Science Toolkit. There's a systems thinking toolkit, and it was supported by the Royal Academy of Engineering. Yeah. And I still refer to that when I'm trying to articulate a complex problem. And I've been doing this for 30 years. So reminding ourselves of the tools we have available, I think, is something that we can do. And if you type systemsthinking.gov.uk, you can find it. The second thing, and it comes back to, and I really liked your point there, Yasmin, about that sort of local ownership of challenges in that sort of context. And I think something that is a bit of a corollary to that is about values, and actually thinking, rather than trying to set people short-term goals, having fundamental values to which an organisation commits, and that being the mantra. And I was with, and I think I can share that, I was with Rolls-Royce this morning for a university meeting, and they were talking about how the value of safety is being absolutely communicated within that engineering organisation. And they know that that is something that is coming right from the top and is embedding through the organisation. And so I think the value of values is really, really helpful. The last example I'm going to give is about gardening. Because gardening is something I do a lot of, and it's basically science and engineering in a complex system. And I've lived in my particular house for 6 years now. And each year I take photos and I write down what I do. And I am able to start to spot patterns. I start to learn what works and I learn what doesn't work. And it comes back to some of the points you were making about patterns. It's sort of scientific. I'd love it to be more scientific than it is, but it's frustratingly have too many complex variables. But learning about those patterns and actually recognising there's an emotional response in the context as well, I think is really important. And it comes back to the point made earlier about time. Complex systems evolve over time. They have emergent properties that sometimes take us by surprise. And so thinking about the way in which we can have tools that enable us to spot patterns in a complex context, I think, is really valuable.
Brilliant. And I now know why I am not succeeding in my gardening as Sarah is. Guru, you've got 1 minute to round things off.
Perfect. The basic point here is a systems engineering approach doesn't necessarily have to yield an engineering outcome. Let's just keep that in mind. Let's not be insecure about it. For example, let me go back to where I started this conversation. We talked about the Ebola crisis in Africa. How did we manage to achieve the goal of people not touching the deceased? It turns out a mentor of mine was an anthropologist, and a few colleagues in the community ended up using a proxy for the dead bodies. It's no advanced technology. It's actually a banana tree trunk. You just move all the properties of the deceased into the trunk, and they use that as a substitute for bathing, kissing, and worship and whatnot. And that's all it took. It doesn't have to be a gadget or has to have a market value. And I think that's where we get into the philosophical domain here. So let's be clear that a systems engineering approach doesn't have to yield an engineering outcome. If we are comfortable with that, I think we can make tremendous progress.
Wow. Well, one of the joys of being a chair of a panel like this is I've basically had the best tutorial. So this is like fantastic upskilling for me, and I'm sure for lots of us in the room. You've given us so much food for thought. So hard to pick out takeaways, but two that I will be carrying forward out of this room is I got that feeling around the humility that we need to bring when we tackle these problems that might be labelled wicked. And that's both in terms of remembering to interrogate why things go right, and in terms of properly respecting, cherishing the opportunity to learn from the stories about things that haven't gone right. And actually, I've often, when we talk about systems approaches, one of my favourite phrases is, when we talk about systems and engineering, they are socio-technical systems. They are human beings involved in that. But I think today what I have reflected more on is that we also need to think about the engineers as human beings, not just the human beings impacted by the systems. And it just reminds me of two of my favourite little snippets from Guru's book. One is an expert, a fire safety expert called Luke Bisbee, speaking post-Grenfell, who makes this very kind of bold a statement that my definition of an expert is someone who's profoundly aware of their own incompetencies. And the other that struck me was this idea as engineers, like nurses, being professional caregivers, and the idea that engineers need moral and emotional responsibility towards the engineered systems and infrastructure that they create. And so that's where I'm going to end things. I hope that you have enjoyed this as much as I have. I'd like to thank our brilliant panellists for their very erudite contributions. And I'd also like to thank my colleagues who have helped organise this, including Maureen and Marianne and Angus. I know there are others, but you'll forgive me. Yes, thank you. And a quick request that any of you who have a moment can just respond to the email we'll send inviting your feedback, because it really helps us to keep refining the events that we put on to make them as useful as possible for all of you. And now I think we definitely have an appointment next door to carry on this discussion, but maybe with a glass in hand. So thank you again for joining.